Alright, thank you for joining me today. I'm going to be talking to you about equivalent expressions. So let me go ahead and get you some up-to-date vocabulary here. First of all, what equivalent means. That's really just a fancy word for equal. Okay, so when we're talking about it in terms of math, we're usually talking about two expressions that are equal. Or in some cases, you may have heard it used with fractions, like 1/2 is equal to 2/4. The next term here would be expression. Keep in mind that an expression is typically a combination of variables, numbers, and operations. So in this case, you can see the examples below. 3x plus 5 and 2x plus 3 squared would be examples of expressions. Next, greatest common factor. That's something we will actually use today as we work through some of these problems that we're about to do. And that's simply the largest possible number that divides evenly into two numbers without a remainder. Also, we'll be using factors. Factors are two numbers when multiplied together give you a product. So in other words, below you can see the examples. 5 times 4 is 20. That would mean that 5 and 4 then would be factors of 20. And then the distributive property. The distributive property, you can see the best thing I can do here is just show you the example. When you do the distributive property, you're going to use multiplication. It's typically shown by a number directly outside the parentheses, as this 2 is, and you need to multiply that 2 in to whatever expressions are inside the parentheses. So you can see your final product then would be 6x plus 10. And we'll talk about why you couldn't simplify that down further in just a moment. Alright, so let's look at some examples that you'll be asked to do. Write an expression equivalent to 28x minus 32y. Okay, and what we're going to be using here is the greatest common factor. We're going to look at 28x and 32y, and we're actually going to ignore the variables. Okay, the variables here are not really going to play a big part in the problem. We're really just worried about the numbers. So I want you to start thinking about what the largest number that could divide into 28 and 32 would be. If you can't remember that, we can use a strategy that we talked about on another program. Using the ladder method, you can figure out the greatest common factor by simply dividing these numbers by 2 if they're even, or if they end in 5s, you can divide them by 5. Our easiest option here is 2 though, because they both are even numbers, so we know that they're divisible by 2. So we divide 2 into 28, we get 14. 2 into 32, we get 16. So in this case, we can actually do it again, and we get 7 and 8. Now, is there a number that can divide evenly into 7 and 8 together? No. So that means we're finished. The numbers that are to the left here are multiplied together would give us our greatest common factor. All right, so in other words, 28 and 32's greatest common factor is going to be 4. What you will do on this problem is write that number outside the parentheses, like so. Then what you'll do is you'll take that number and divide it into 28. 4 goes into 28 7 times. Okay, and you'll continue. Again, you don't necessarily do anything with the variables, but we can't get rid of them, so you need to make sure that the variables do stay with the value that you divided into. Alright, and we're going to do the same thing now. We'll involve our minus sign, keep it a minus sign, and now we're actually going to divide 4 into 32, and that's going to go 8 times. Alright, and what we've done now is we've done what's called just some basic factoring. Okay, you'll get into some more complicated factoring on down the line. We've basically done the opposite of the distributive property, which we'll see in a moment. Whereas in the distributive property, you're multiplying in this case we're dividing out, okay, out of the parentheses. This is actually your final solution here, or your final equivalent expression for this particular problem. Alright, so now that we've seen one, let's take a look at another one here. Write an equivalent expression for 20x minus 5. Okay, so again, your thought process should be what value can divide evenly into 20 and 5 both. Well, in this case, we probably don't have to set up the ladder method because there is only one number, and that's 5 itself. 5 will go into 20 4 times, and will go into itself once. Okay, so again, you're just looking at these values, 20 and 5, and determining what the greatest common factor is, and that's what you will divide outside the parentheses. And you'll notice, just to show you, if you multiply it back in to both expressions, you get the same exact thing you just started with. 5 times 4 gives you 20, and 5 times 1 gives you 5. So it's more or less just kind of like a circular mathematical reasoning type of problem where you're going to go one direction, and then now we're going to ask you to go back the other. Let's take a look at that type of problem right now. And that would look like this. You can see that's pretty much what the answers to our last two problems looked like when we were finished. So now what they're going to ask you to do is take this and multiply in. So whatever number is outside the parentheses gets multiplied in to any numbers inside the parentheses. And again, I know that there is a variable x inside there. However, that x doesn't play any part in the math yet. It will eventually down the line, but right now, not so much. So 5 times 2 is going to give us 10. Bring that x along because it is part of the problem. And then 5 times 3 is 15. You might be asking, how do I know if minus sign goes there? Well, if there's a minus sign in the problem, you keep it a minus sign for right now. If it had been a plus sign, it would be a plus sign. All right. So your answer to this for an equivalent expression would be 10x minus 15. All right. So let's look at one more here of those. It says write an equivalent expression for 4 times 5x minus 4. And again, you're going to use the exact same strategy. Whatever number's outside the parentheses gets multiplied into any numbers inside the parentheses. So in this case, 4 times 5 is going to give you 20x, and 4 times 4 is going to give you 16. And you just simply write it like that. All right. So here's just a couple of quick small equivalent expression problems. They want us to take what we're given here and come up with new expressions. Well, this is also what we call combining like terms. We have 1y plus 1y plus 1y. All right. So to simplify that, or to write an equivalent expression, you just simply add up the numbers that are in front of your variables there. Since we can do that since they are all the same variable. If they weren't all the same variable, we couldn't do it. But in this case, we have 1y plus 1y plus 1y. We can write one expression for that, and that would be 3y. All right. Letter B is something that we actually saw in another program that dealt with. When it's multiplication, you're dealing with repetitive multiplication or exponents. Okay. So in this case, the letter would be your base value in your exponent, and then however many there are of that letter would be your exponent. So there's 1, 2, 3, 4, 5 z's. All right, so that's going to be z to the 5th power. That would be your equivalent expression there. And then letter C, you can basically compare that one directly back to letter A. We're back to addition, so that's going to be 1n plus 1n, or simply 2n. So if we're comparing these three problems, you can see when it's addition, the value goes in front. When it's multiplication, repetitive multiplication, that's when you're talking about exponents. All right. And how are they going to give this to you in other contexts? Well, this would be one. This is more or less a geometry context. They want you to write two expressions that are equivalent for the following. Well, what we can do here is we can actually look at just simply adding these up. We can add up 5x plus 10x plus 5x plus 10x. And we can set that equal to our other equivalent expression. Well, our other equivalent expression would simply be the combining of all of the x's here, okay? You can combine just the 5x's together to get 10x, and you can combine the 10x's together to get 20x, or you can simply combine them all together. If we do that, we have 5 plus 10 plus 5 plus 10. So that's going to be 30x. All right, and all I did there again, notice I just pretty much ignore the x's. They don't play a big role in many of these problems as of yet. So that's going to be 30x. And those are just two equivalent expressions. One other expression, as I mentioned before, could be 10x plus 20x. That's just another way to write it. And you can see all I did there was add the 5's together and add the 10's together. Any of those would work for two equivalent expressions. All right. So then to give you a word problem here, the practice soccer field at the local high school is 3x plus 5y yards long. The regular playing field is 2 times that size. Write an expression showing the length of the regular playing field. Well, again, we have our expression 3x plus 5y, and our key term in this problem is 2 times. That means multiplication. So we could get fancy with this. We're multiplying with parentheses. Okay, and the reason why I know we're multiplying with parentheses is because 2 times the size of the field means 2 times the entire expression, 3x plus 5y. So we want to make sure that when we write our expression that we include both values, 3x and 5y. So that's where distribution will come in. So we multiply that in. 2 times 3 is 6x, and 2 times 5 will give us 10y. So there's 2 different expressions that you could use. Typically what they're going to want is the most simplified version after the distribution. This has been a quick tutorial on expressions. Thank you for joining me.